and welcome. This is Leetcode 15 three-sum problem. It's a medium, and it's one of the infamous problems that are presented in the recent technical interviews at software engineering or related software engineering roles. This is a continuation of the two-sum problem. I will link it in the description. I highly recommend you go through that, although it's an easy problem, but highly recommend just going through the rhythm of how that kind of problem is solved, exploring the other solutions, and then jump into this one, because this one kind of stretches that base idea of how to solve two-sum with far more variables and constraints presented to the problem. So with that being said, let's just go ahead and take a look at the problem. So given an integer array nums, return all triplets, which is just all three variables, where I doesn't equal j, and I doesn't equal k, and j doesn't equal k. And where it's trying to tell us here is the indexes don't equal each other, so they're very unique. And the ultimate goal here is to say, hey, add all these three variables to 0. They need to add up to 0. And another constraint on top of that within the indexes is also the triplets themselves cannot be duplicates, meaning, and this is done very well in this example here in example 1, -1, -1, and 2. Is this one of the solutions for this input array. And then you got -1, 0, and 1. As you can see here, these are fairly different, distinctive triplets. So one thing that this problem is asking for, which in my opinion why it gets promoted to a medium, is make sure that these are all unique values are being shared in the result array. So with that being said, this problem needs to be tackled by first sorting the array. So you need to first sort the array, and that is done by, in Python, you call the name of the array, which is what is it called? Nums. Yeah, nums dot sort. And then second, you need to iterate through the loop and check, hey, go through a series of checks. So that's like the very, very general idea, obviously. But first, we're going to explore the brute force approach and then jump into the optimal approach to this problem. So, sure, talk about that later. But the brute force approach for this problem is a little bit not the cleanest, in my opinion, but it's a solution. And it's the most natural one that's going to come up to you if you've done two-sum, where you're going to do 3 nested for loops, where the first loop is going to be I. It's going to be starting at the first index, and then j is going to be followed by I. So j is I plus 1, and then k is j plus 1. And all you're doing is you're checking every single possible combination that adds up to that base condition of summation of these three values add up to 0. So let's do a quick dry run of that. So we have -4, -1, and -1. That does not equal 0. That adds up into 4, 5, 6, -6, and -4, -1. K is going to keep on going down the array first. It's going to equal 0, -5, and -4, -1, and plus 1. So that's going to be -4. All this, we can keep going through this, but I can jump, and you can do this on your own, and I highly recommend sit down and go through each single iteration, but given the time constraint, I'm just going to jump into a point where we start running into the solution example, where let me just erase some of this stuff. I starts to become 1. So once we iterate through, k has gone through this, and so did j. We start over and increment I. Once I is incremented, so I is here, and you got j and k. Right off the bat, -1, that's a -2. So let me erase this, sorry to confuse, but this will all make sense here in shortly. So we got -1, -1, and 0. So this is, again, I, j, and k. And then you got -1, -1. K is also being incremented, so it's a 1. So this is just going to equal to a 1, a -1. And then k is being incremented. It's all the way down here now at this point. And -1, -1 plus 2. And that equals 0. So here we have found our first unique values that add up to 0. So we're going to append this. I think we're going to call it result as our sorry, it's a little late. We're going to append this result as we're going to append these values into our result array, which is our answer array that we have initialized way earlier in the code. And once we do that, we continue to go through this loop. So at this point, K's continues to go through. A little track here. So we have I is right here. I is right here, J and K, and that is also a valid solution, so it would be -1, 0, and 1. Now, one thing that you might have been questioning yourself as you're going through this is, how do we handle unique cases? How do we not always get duplicates? Because this is a serious concern, and that's extremely valid. The one thing that you need to always do right at each for loop, so once we have, here I'm going to write just a simple pseudocode. Actually, I'm just going to copy over the code solution, then that'll make it a lot easier and a lot quicker than me writing all this stuff now. So I'm going to erase some of this stuff. I'm going to come over here, and let's bring this guy. The wonder of technologies. Anyway, so right here, this is the brute force algorithm. I'm going to choose a different color here to explain what I'm talking about. So first, you have to sort the array, initialize your result value that you're going to return, since that solution is requesting you to return a value. And then we're going to jump into the first loop. So this is I, right here, which translates here. So imagine we went through the loop, and we've already addressed some of the already went through half of the iterations of the combinations that we have been possibly going through. So we first go through I, and then before we continue, we check, hey, as long as the index is above 0, which means that we have passed our first check or gone through not the first possible combination, but we have gone through the second time. Now we're going to I plus 1. And as long as the current value is not, we haven't seen this, so this is basically seen. If we have, we want to skip. We want to skip over that. And the same thing for J. J is exactly the same way. And so is K. The only difference is at K, we have our final check here, which I know looks disgusting, but bear with me. Here we are checking, does this all equal to 0? If so, then we append into result. If not, then we continue. This way you are satisfying the requirement of finding which combination values add up to the array, add up to 0, sorry, and they are unique. The problem, as you can see off the bat, is given that we have 3 nested for loops, your time complexity is O of n cubed. Now, you would say, oh, well, you're using a sort function into your, so wouldn't it be actually n log n plus n cubed? And you'd be absolutely correct. The problem is, in time complexity, we're always accounting for the worst case and what we care about as being the and if we have a case where both parameters are equal, we will keep it sure. But really, when this is being decomposed, n cubed is a lot greater than n log n in the scale. When we graph this up, n cubed looks like this, while n log n I think looks something like this. And there's a great difference. So this basically gets summed down to n cubed. So that's a little trick here in time complexity. But that being said, let me go ahead and jump into the optimal solution, which I think once you've seen the brute force, the optimal solution will kind of make also a lot of sense. So I'm going to copy this guy over 1, 2. And the optimal solution is using a 2-pointer technique. We're still going to sort like we did before, but instead of using 3 nested for loops, we're going to go down to 2. First being I, and then the second loop, which will be our while loop for our 2 pointers, which will be L and R right here. And we're going to always check, hey, is my current sum greater than or less than 0? If it's greater than 0, then we would tell the right pointer to decrement by 1. Because again, this is a sorted array, so most likely that we overshot and we added a value that we shouldn't have. So let's keep going down. Oh, but we have like over here we have a -4. So if it is less than 0, so let's do current sum. And current sum is going to be nums of I plus nums of L plus nums of R. And if that current sum is actually less than 0, then we would tell the left pointer to decrement by 1. But if we hit our else condition, where we have a state where the left pointer and the right pointer have found a value that, and our for loop major I index has all summed up to 0, then we would like to append. So result dot append current sum. And we would like to update our pointers. And to make sure we're not accounting for duplicates, at this else condition, we can pick one of the pointers. We can either go with the left pointer or right pointer, but the point here is as long as the left is less than the right, or, and this is in case we're using the left pointer here, and nums of left equals nums of left minus 1, we would like to continue. Oh, sorry. Continue. Well, here we are skipping it, so technically I'm not wrong here. It's just that using continue is wrong. So we would tell the left pointer to keep on incrementing until we come to a point where the left pointer and the left pointer is at a value that we haven't seen yet, and then we want to account for that. So that being said, I would like to go ahead and just jump right into Leetcode and show the algorithm and kind of do a more dry run on that. But hopefully this made sense and is giving you an idea where we're kind of heading towards to. But to share the time complexity, I don't know, I keep choosing the razor. Time complexity here would technically be O of n squared. And yes, you are correct if you were thinking about n log n for using the sorting. But given that, as we discussed earlier, we have an n squared plus n log n, the n log n will be dropped in a higher data schemas in the real world. So we would only care about the n squared computation, and space complexity for both technically be O of 1 as well, because we're not using any data structures to store any of these variables. Well, I'll take that back. We are storing a variable, which is our result array, and we've initialized it. So I guess that I'll get back to you on that. But yeah, thank you. We'll go ahead and jump right into the code, and that would make a lot more sense than at this point. So let's go ahead and try to do that. All right, so we're back. So we're going to try to implement here the two-pointer approach. I don't know why I'm yelling, but I apologize. So we'll go ahead and give this a try. So we're going to first sort the array, initialize our result value or declare it, and then for I in range, if I can spell, if nums. Here we're going to check the duplicate condition that we talked about earlier. So if I is, as long as it's greater than 0, we have passed our first check or first stop. Now we're looking at other duplicates. And nums of I equal to nums of I minus 1. We will continue. Let me write this, skip over this duplicate. And then we're going to identify here our left and right pointers. So we have I plus 1, and we have the length of nums minus 1. While left is smaller than our right pointer. And here we're going to calculate our current sum, which is equal to nums of I plus nums of left pointer and nums of our right pointer. Not while, no, the third loop. If current sum is greater than 0, then we're going to tell our right pointer to decrement, move down the array. Else if current sum is less than 0, we're going to tell our left pointer to move up the array. Else we have found our we have found our values that will add up to 0. So we're gonna append nums of I. I was trying to find a shortcut, sorry. And nums of left, nums of R. And we're gonna tell our right and left pointer to decrement and update. Right here also, to make sure we get rid of any duplicates within our window between the left and the right pointer, we're going to tell, and making sure that the left pointer itself or the right pointer are not having duplicates. Sorry, one of the pointers, we just pick one of them. We say while left is smaller than right, as long as we're not violating that base condition, and nums of left equal nums of left minus 1. We're going to tell the left pointer to keep on moving forward until we find a new one. Make sure I'm in the right indentation. Return result. So let's go ahead and run this. Oh, I missed. Else if. Okay. I'm confused. Oh. Okay. Sorry, that was a little misspelling. But yeah, here we have passed our base cases, and I'm going to submit the solution, make sure it works. Perfect. And then we're going to take a look at the time complexity that I mentioned earlier. It's O of n squared, and space complexity, I think it should be O of 1. Oh no, it is O of n. Oh yeah, because we have technically, this is a data structure, as I should know this. I apologize, I had not picked that up. But yeah, so this is the attempt in solving a three-sum array. I'm going to post in the solution for the brute force that I found to be the most natural that came to my mind first, and then on top of that, you would build and come up with a two-pointer. This is something that you would discuss with your interviewer, and it's definitely a win whether going with the brute force first, and then developing and improving it will be a great win for you. So best of luck, and I hope this video was helpful. Have a good rest of your day, evening, or morning. So